right, now that we've gone over all of that, we're going to go ahead and get to identifying geometric sequences. This means that we need to go ahead and find the ratios of the terms, and or we need to see what they're multiplying by each time if it's not, if it's pretty clear to see. So for A, we go 6, 12, 20, 30, and 42, and then so on and so forth. Now, since we are identifying if it's geometric or not, we're going to write out those ratios, and we don't need to find out what type it is or anything like that. We just need to see if it's geometric, yes or no. So 12 divided by 6, that's 2. So it's multiplying by 2 on that one. And then 20 divided by 12, that's 5/3, so that's 1.67-ish. You can already see right there, it is not constantly growing by the same rate. If we continue on, you see that this is 3/2, it's 1.5. You see that growth rate, it's getting smaller, and this last one is 7/5, which is 1.4. So this is getting smaller. This cannot be geometric. It's not a constant rate. The ratio is not constant. The rate, ratio, those are like equivalent terms. That's going to say what it's multiplying by, or the second term divided by the first term gives you that ratio. There are a million different ways to refer to these things, as most things in math. All right, B. Got 256, 64, 16, 4, and 1. Okay, so 64 divided by 256 gives you 1/4. Plug it in, you'll get 0.25 in your calculator. 16/64 is 0.25, or 1/4. Hopefully you see that 4/16 is 1/4. And 1/4 is, 1/4. So B is definitely geometric. It's being multiplied by the same value each time. That is a constant growth. Actually, it's a constant shrink in this case. It's 1/4.